I appreciate it. Thank you. Thanks for having me, Michael. I'm not going to spend too much time on this. My name is Raju. Be your semi-host, co-host, or whatever you call them for the next 45 minutes or so. And like the topic said, we are talking about developer productivity engineering, and um, just to sort of set the backdrop of what it is that is the thesis of our conversation today. It's actually a relatively new engineering discipline, and you know, people like me, the folks at Gradle, have felt that sort of spreading the message to fellow developers, organizations, as to the importance and potentially uh, finding ways to have it incorporated in the culture of companies is important. And so, I, alongside with Michael and No Fluff, decided to sort of put up this webinar, hoping that you all will join in, ask some questions about what it is and why it's important, and we can discuss all that. I have some demos if you are interested in seeing those. But yeah, that would be the next 50 minutes.
Right on. Exciting stuff. And so let's kind of start off because you touched on this briefly, but developer productivity engineering. As you mentioned, this is a new discipline, it is a new pursuit. Can you uh, do two things for us? Define it, but also let us know, as developers, how do we relate to this? Is this, in other words, what's in it for me?
Oh, yeah, great question. And so developer productivity engineering, sort of the name alludes to, fundamentally, it's all about improving the developer experience. So as developers, um, let's just sort of focus on a facet that may ring true for many of us. Um, One of the things that we tend to do quite a lot is build code, right? Whether that's red, green, refactor, whether that is running Gradle or Maven in watch mode, what we tend to do is sort of work a little bit, build the code, make sure everything is okay, and then potentially, push the code upstream, issue a merge request, blah, blah, blah. One facet of developer productivity engineering is about using techniques, perhaps at the tooling level, perhaps at the infrastructure level, to hasten the speed of a build. So just to give you a little bit of backdrop, and Michael's well aware of this, Michael and I share somewhat similar technology backgrounds. But one thing that has always attracted me towards the Node NPM systems or the ecosystem is the speed at which things build, right? The rate at which they start up and the which that they build. And this has become a sort of driving force even in the Java community, with them thinking about JLink and reducing startup times, Quarkus and Micronaut, which Michael is very familiar with, aim at doing this, right? How can we make it so that the idle time that a developer has, whether it's building your code, whether it's startup times, is reduced? So one facet of developer productivity engineering focuses on improving that experience. And the second part, which, I mean, there's several, like I said, this is an engineering discipline. It's very broad in its definition, but tangibly, like you said, what is it for me? Another piece that you might have sort of delved in is, Michael and I are working on the same project. Michael builds his code, everything works fine. He's on a souped up, Windows machine. I'm running on a crusty old Mac OS X. I run the same build and it breaks. And how do we figure out what happened, right? So sort of debugging builds is another facet. So Michael's put up a little, oh yeah, I love that comic. In fact, I use it when I give presentations on developer productivity engineering, which is that one. Is we are waiting for the code to compile, code carry on. We understand that build times take a long time. So that would be, two selling factors. There's a lot more, But I think fundamentally, the thing that strikes a chord with me a lot is those two pieces.
A great question just came up in the chat, by the way, is how do you define and measure productivity? And I think you kind of touched on this in what we're particularly talking about is not how many story points you ship in a sprint or how many lines of code you crank out per hour. Um, and yes, I'll put that in the chat there. Also, if you're watching the recording, just to kind of close the loop, if you're watching the recording, you didn't see the picture that I put up. The picture that I put up was the classic XKCD slacking while we're waiting for code to compile. But pulling back to that original question that came from Claude. How do you define and measure productivity? Oh, thank you, Phil, for linking to that. That's great.
So productivity is obviously, to a large extent, very vague in its measurements, right? We've tried a slew of measurement techniques, and all of them seem to fall short. But personally, what I like to think of is how much idle time do I have, and what is the gap between me potentially making a change and it sort of hitting the main line or the main trunk or the main branch, right? Now, of course, you can extend that. If you bring in the DevOps fundamentals, then the next measurement gap might be lead time. Is I have made the change, how long does it get to production? But insofar as our conversation goes today, I think that when I'm thinking of productivity, I'm thinking of that gap. Is I'm working on something. What does it take for me to get that into a mainline or potentially in a development environment for other people to share or see or collaborate on, or at least verify?
And if I may, one thing I would
Mhm.
add is for me, that I know No Fluff tweeted about this, and I think it really hit the nail on the head for me. It's that flow state. It's getting into the zone. That's what I really strive for, and that zone is fragile, and it's every time we have to, somebody calls a meeting. I get pestered on Slack or Teams or whatever we're using today. Skype if it's 20 years ago. But it's all of these things that take away from that. So one of my goals is to figure out ways to get into the zone and stay into the zone. And part of the developer productivity engineering aims to support that.
That is very accurate. In fact, when I sort of got involved in aiming to spread this message, when I saw the initial sort of elevator pitch, my knee-jerk reaction was, this is all about flow, because anytime I'm working, the only thing I'm watching out in my console window or whatever tool you use is for that green light to show up, right? My build's passed, my test passed, and everything is good. And anytime that takes longer than it should, two things happen. One, now, if I see red, as long as that's a deterministic red, that's helpful. But if it is a non-deterministic red, the things failed because something was not wired up correctly, or I couldn't reach a repository, or I couldn't download a dependency, or I had a flaky test, which is the bane of, I think, every developer's existence. That's a problem because now it takes me out of that zone. So one of the first things I quoted, and I do quote when I give a presentation on developer productivity experience or engineering, is a quote from, and I can't pronounce his last name, but Mihai's book from 1980s, which was Flow. And recently, there was a book called Deep Work,
Cal
by Carl
Newport.
Newport. Yep. And I quote both those books because I think, oh, there you go. There's the book. I actually quote those two books because I feel that developer productivity engineering, the part that rings true to me the most is that part. Is I don't want to be hopping out of my flow because the gap between me and any kind of verification or getting it into the main trunk, that conversation I'm having with the tool chain, right? Whatever your build process is flaky, flighty, slow. And this has deeper ramifications. So Michael, thanks for bringing that up. Let me see if I can share a quick sort of little slide I've created. How do I do that? So share screen. For a person who works with technology every day, I am terrible at this thing. Let's see.
While you're doing that, I'm going to plug the rapper Standard Out, who has a channel on YouTube. There's a now I would argue that it's not safe for work, but he's a oh no, stop. But he's got this whole series of kind of parody rap songs about what it's like, the day-to-day life as an engineer. And
you always seem to find the most interesting of I'm trying to find the right phrase for this. So these loose connotations with developer. There was another comic strip you sent me a while back that I check out every once in a while. I can't remember what it was. But anyways.
But check it out. It's I'll post it in the link. Again, not safe for work. There's some language in there. Red, green, green and red, red and green. My terminal's looking like a Christmas tree. Please don't tell me to TDD. I do maybe test after code, MTAC.
That's actually, so is it a YouTube? Like, is it
yeah, I'm going to throw it in the chat.
Yeah, I love that. But I don't know if you can see my screen. Can you see my screen?
Yes.
Okay. So excellent. When I
think that is the mantra for 2020, by the way.
Yes. Can you see my screen? Which is from the 2018? Can you hear me now, or whatever that was?
No.
So the more I thought about the essence of flow when working, led me to start thinking about bigger things, right? So if we sort of take this journey, right, and we start at the top and we work our way to the right, right? So if you can improve your time to build, then naturally you have less idle time, less context switching. And one thing I've learned, Michael, maybe you can echo this for me. Working on a project a while back, the build times were about 6 minutes between, like, every time you built your code. And so I would make a change. No one was running build in watch mode, because you don't want, every time you save the file, you're not waiting for 6 minutes. We would start up the build. And then I got in the habit of checking Hacker News or Twitter or whatever. And then I noticed that even on projects where things were moving faster, my mind would still shift to, maybe I just fired a build. Now my brain tells me, go check Hacker News. Although the build was like, less than a minute. And so what happened is I got in the habit of sort of coming out of flow, because I was so ingrained in this idea that whenever I start a build, it'll take 12 minutes or 6 minutes or whatever that was. So it was habit forming to some extent. And so to your point, right, there's this piece of context switching that comes into play. And if you can reduce both of those, what you get is not only the sense of more productivity, but also you're not rebuilding that house of cards that we have to build every time we're making a change, right? But you're keeping all these pieces in your head, and you check Hacker News and you come back and you're like, what was I working on again? So that's where I sort of came with this sort of idea, which is a much more focused developer. But then the other side to it, right, which is if you go down this pathway, well, if your build is fast, you're going to build more often, which also typically leads to every time you check or verify your code, your change set is a lot smaller. So you're not making 15 changes because you only want to build once because your build time takes 6 minutes. You are rather building as often as possible, and potentially even releasing smaller change sets to the rest of your team. So your merge requests are smaller. And the old adage, right? If you have a 2-line pull request, you will get 30 comments. But if you make a pull request that has 30 files changed, everyone just signs off because no one says, I'm going to look and read those 30 files. So the point I'm trying to make is
Rubber
you
stamp.
catch, there you go. And so you shift left by virtue of the fact that you have less idle time. So to answer Claude's question, productivity may be nebulous, but the side effects of it, even at a personal anecdotal level, are not, right? You can see these sort of come into play, whether that's just your own mental sanity, whether that's the sanity of your colleagues, or whether it's how quickly are you trapping bugs, right? Or I shouldn't say necessarily bugs, but perhaps missteps or oversights. Instead of waiting for CI to build at night, if you can build right now on your local machine, you're automatically shifting left. So hopefully, Claude, that answers your question. And Claude says the REPL, sure, the REPL is a good feedback loop, but how many languages have a true REPL? I can think of
And
only one family of languages that has a true REPL. Everyone else fakes it out. Right.
And to define that for anybody listening that unfamiliar with the term, read, eval, print loop.
Very popular in the Lisp language, Lisp family of languages.
Closure.
Yeah. So that's where I would come from, is sort of this idea of productivity. Yeah. Hopefully that answers the question.
So what we're getting to is developer productivity engineering is focused on what we'll call acceleration technologies. Is that a fair statement?
To improve your build times, yes, there is I mean, again, this might be phrasing that might be something that we've concocted at Gradle. But yes, acceleration technologies being a sort of a placeholder to find ways to improve your build times. Yes, absolutely. Mm-hmm.
And can you define some of those a little more concretely? Some examples of those, because definitely I see how this really feeds directly into the build time.
Absolutely. So if I were to ask folks in the room, looking at your build, what are your biggest sort of offenders in increasing your build times? And most people would say, well, there's building the code because it's a pretty IO heavy and a CPU intensive process, right? If you have big projects, and Paul just nailed the second half of it for me, which is running tests. And Phil, to your point, tests are correct. Deployments, at least in the context that I'm talking about, deployments would be a step after the build process, right? So build and test. And if you can improve build times and if you can improve test times, you automatically can shrink the amount of time it takes to take your build. So the question is, what can we do to improve build times? And there's, at least within the Gradle sort of tooling, which is the Gradle Enterprise appliance, there are two specific pieces. One is called build caching. So Michael, you've probably seen this all together and perhaps too real for you. If you are, let's say you're working on a branch, right? You're working on your little feature branch and I am working on my feature branch and I issue a merge request. And being the diligent developer you are, you sort of commit your code temporarily or stash it. You pull down my branch and you run the build so that you can verify the changes. Now, I built my code before I pushed it upstream, and you build the code on your machine locally. And there's a good chance that when I pushed my code upstream, CI built it, right? So
sure.
Between those three things, if there was a way for you to be able to use the results of the build process that the CI machine produced, your build process automatically becomes faster, right? And what I mean by that is, if you don't change my code and you just build it, what if you could just use the outputs that the CI machine produced in your build process? As long as everything is identical, right? So you are running Windows, the CI machine is running Windows, same Java version, same, everything else is the same. That reuse is what we refer to as build cache. So given certain constraints, as long as your CI machine is sort of the overarching piece in your infrastructure that builds everyone's code all the time. Every time somebody else builds a piece of code on their machine, let's say they just check out the master branch and they build it, why are they building it all over again? Why can't they simply use the outputs, the results that your CI machine produced, right? If you could, your builds just got faster. But let me give you a more relevant example. You were working on a branch and you pull down my branch and you built it and you verify my merge request, you push it upstream, then you switch back over to your branch and you build again. What happens in a tool like Maven or Gradle right now? When you switch branches, which means the entire code base has changed underneath you, what happens when you build again in your previous branch?
Well, I might as well have typed clean build.
Exactly. You lose everything and you have made no changes. You built your branch, you committed your code, you switched over and you came back. Why can't you reuse the results of your previous build? And that's what build caching is all about. The ability for you to not only have a deterministic algorithm that allows you to cache the results of a build, but potentially even share it. And then typically the sort of technique that Gradle Enterprise folks advocate is that your CI machine sort of publishes its build results, your build outputs. So when I say output, I mean you compile a file, a Java file, you get a class file, right? That's the output. If another developer can reuse that class file, you don't have to build. You just have to copy that file from some location onto your machine and you're done. So
And
what
the
you
tests have
get,
already passed as well.
correct, and there's nothing to do because Gradle can verify you haven't changed the tests. You're running on exactly the same system that the CI machine is running on. It means your tests result will be identical. There's nothing to run. So that would be the sort of benefits of build caching. And just to put this in contextual, this is something where it looks like. So developers maintain a local cache of all of their results. CI not only maintains a local cache, but it actually pushes over to a remote cache. And this is all part of the sort of Gradle Enterprise setup. And then anytime a developer builds, Gradle can actually check the remote cache and say, this combination of inputs, so this Java source file in this JDK using this operating system and all kinds of other constraints, if it's already been done, don't even bother building it, just pull it from the remote cache and you have your outputs. And so that's one sort of powerful technique called acceleration technologies that allow you to improve build times significantly. Copying files over, especially large projects, copying files over the network is usually much faster than the computational it takes to build them to begin with.
And there's a comment in here as well in the chat from Mark. Parallelism of running tests for code I was recently working on 2 minutes to build and package the code, but 3 hours to run all the tests. Comprehensive end-to-end test using Selenium to interact with the web client.
So Mark brings up a great point. And let me ask this question to you, Michael, since again, okay, you're my scapegoat. Most CI machines, at least in bigger, medium to big size organizations, typically run in some sort of a cluster, in a farm, right? So you can actually run the tests in your CI by fanning them out to all of these agents, right? So you can parallelize tests on CI. The question then is, why can't you parallelize that same infrastructure on your local laptop? In other words, why can't you use those agents that are available from your local laptop? And the answer is, so far, no one's done it because it's a complicated process. Fanning out tests to a server farm and then pulling back the results involves two things. One, knowing how to break up the tests and shipping them out, and then collating the results so that you grab every output in a logical order and produce a report of some kind, right? Pass, fail, whatever. So Gradle Enterprise actually has just recently introduced something called distributed testing. And so it's a pretty complex, I shouldn't say complex. Infrastructurally, it's a bit complex because you're basically taking every developer's laptop and sort of connecting it to this server farm so that when you run tests on your machine, you're actually spinning out to all of these agents, and somewhere Gradle Enterprise will collate the results and bring it back to your laptop. So you have the same power that CI does. And so you can actually improve test times significantly. I mean, we are talking 50 to 60% if your tests are distributable, right? If they're parallelizable, your local machine works like your CI machine works. And you're not any more constrained. You know, typically what do you do? If you have a 4-core machine, you can ask Maven or Gradle to run 4 threads in parallel. That's it. That's as best as you can get. But if you have an entire server farm available to you, do whatever you want. It's almost like the Google Borg project, which allowed people to like fan out and work everything distributed. So to Mark's point, yes, distributed testing or parallelization of running tests, both from your local machine and from CI, using this distributed technique, distributed testing facility that Gradle Enterprise offers. It makes a huge difference.
Which also gets us to Cheryl's point. What we need is more power.
Cheryl's getting it, absolutely. And the power is there, right? Tools, and again, Gradle Enterprise, being a commercial product from Gradle, sort of supports these ideas of developer productivity engineering. Is how can you make your developers more productive? How can you empower them to do things that so far have been relegated to CI machines, to Mark's point, running nightly, right? If you can bring that power to the developer, that's immensely powerful. It's immensely empowering and makes them, quote unquote, productive, right? Whatever that term means in whatever sense of the word.
Right on. So put this all together for us a little bit, if you would. Because you've got a couple different pieces. You've got build cache, you can cache the results of tests that we're not wasting cycles doing work that's already been done, and provably so.
So there's a lot of moving parts here, right? And you're right that it can be a little overwhelming. So if, perhaps this is just one piece of the puzzle that we've talked about. Sorry, this is 2 parts of the same puzzle that we're talking about. So if you focus on this picture, if you just look at the build cache piece of it, right? What Gradle Enterprise is doing is it's providing you this sort of tool that is essentially taking developers and CI and making them peers, right? So that's one piece of the puzzle, which is between the build cache and distributed testing, which are 2 separate components of Gradle Enterprise, you're making developers and CI peers. There's no difference between running things between your machine or on CI. Now, I'm not saying CI becomes obsolete. There are some things you only want to run in CI, like if you're doing smoke testing or, real world, like security penetration testing, where you actually need a fully deployed application. CI has its place, but fundamentally, those 2 pieces get you closer to CI. The other piece that I do want to sort of quickly mention is this thing called build scans. And this, to me, is actually a facet of DevOps that comes into developer productivity engineering. So I know a lot of people, when they think about DevOps, they're thinking about tooling and automation and blah, blah, blah. To me, DevOps is about one thing fundamentally at its core, which is collaboration. And the collaboration is usually a function of transparency. In other words, if I can codify my infrastructure and my configuration management and my build and my database migrations and my source code, if I can codify all of that and put it in Git, I can have more people look at the same thing and improve the transparency and enhance collaboration, right? Different people with different specialities can step in and say, whoa, 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 I don't think you need this elastic load balancer here. You could make this architectural decision and change your network topology to support that. Now, to the point I was making earlier, let's say I built my code and you built the same code. It works for me and it doesn't work for you. How do you go about debugging that? And the reason why it's so hard to debug is there's no transparency in what a build looks like. So what Gradle Enterprise supports is this idea of a build scan. So if you've done CI work in Jenkins or Travis or Circle CI or whatever, there's a console log, but that's only a piece of what your build is. Your build is what tasks were run, what dependency graph did you actually finally result in, what does your infrastructure look like? Are you running on Mac or Windows? Are you running the right version of Java? Even in Java, JDK versions sometimes have subtle bugs that sometimes show up because your machine is slightly different than my machine. So build scans, again, sort of bringing this idea of developers and CI at parity. Building locally on my machine is only visible to me, and building locally on your machine is only visible to you. The only thing that's somewhat visible to the entire organization is what's built on CI. But one part of Gradle Enterprise is build scans, which are essentially everyone's build gets reported in Gradle Enterprise all the time. So to give you a sense of what that looks like, let me make this a little bit bigger. So this is a sample appliance we run. Here are every build that was run in the entire team, all the time, every time. We are not only capturing CI builds, we are capturing every build. And so, for example, let's say this was Michael's laptop, and he was complaining that the builds are failing. I can simply go down. So this is a contextualized, semantic, and marked up build scan. It is essentially everything that Gradle can capture about a build being made visible to the entire org. And so lots of benefits come out of this, because not only can I take a look at your build, right? I can say, he was running on Mac OS X with 8 cores, and he was running OpenJDK version 11.0.4 plus 11. So that's the one way to debug something. Alternatively, you can do even something like this. I can go and say, well, this is my build. So I'm going to click on A. And this is, Michael's build. So I'm going to click on B. And then I can just simply compare the two and get a sense of what went wrong. What is different between my machine, my build that I just ran, and your build that just ran, and okay, so there you go. And so Gradle Enterprise is actually showing you, A is Michael's build. I'm just making an example up here. B is Raju's build. And all these dots are telling you that something was different, right? So if I go to infrastructure, perhaps maybe your build failed because you are running on Mac with 11 and I'm running on 1.8. And so you're a click away from debugging builds. And again, it's all about that transparency. If you can bring everyone to the same level, right, and capture all of this relevant information, things like debugging builds becomes a lot easier. Things like sharing builds becomes a lot easier. Whether that's just you, whether that's your build team, whether that's your CI team, whether that's between developers. So, for someone who, like me, has spent a lot of time thinking about DevOps and tooling and automation, this is just another facet to that transparency.
Oh,
Give me, sorry, go on.
Oh, I don't mean to interrupt, but that piece is kind of huge. I mean, I can't tell you over the last 20 years how many times I've tried to troubleshoot an it works on my machine kind of issue.
Yep.
So that's I don't know. That's kind of big for me. That's what I'm most excited about right now for some reason.
Yeah, and I'm glad, because I'm hoping that you and everyone else in this group gets excited about these ideas, whether Gradle Enterprise is the sort of tool of choice you go with or not. But let's explore that idea a little bit more, right? Let's say you have all this metadata about everyone's build all the time. What else can you do with it? Well, you could do something like this. You could do dashboards that show you build times over time, and you can catch regressions in build time proactively, right? You can say, watching this team's builds over the last, I don't know, a month, I'm seeing this increase. What is causing this to be increased? And in fact, you can do all kinds of interesting things. So for example, this, and again, this is an example I share, on the right-hand side, I know the font's a little small, but these are the mean median times of builds. And I can sort of hover over and say, here it was 333, and here it is 537. So the build jumped by 2 minutes on an average between January 21st and Feb 24th, right? And so now, given that, so it's Jan 21st, I could do, let me just limit this a little bit. And what was it, Feb 4th? Friday 24th. So go back here and go to 24th and just refresh. And while this, obviously this being so zoomed in doesn't give you much, what you can do is go to another tab and simply say, well, I see that this build over here was a lot shorter. So again, I'm going to pick it, and then I'm going to go to this build. I'm going to pick that, and I'm going to compare it. And now I can do comparison to see what caused the regression. Why did my build times jump by 2 minutes in 2 weeks? Because I have all this contextual knowledge about every build. And not only that, right? You can do all kinds of other things. You can see, like if you're seeing, oops, I think I have. Okay, so let's say you're seeing a bunch of failures. Because you have all this contextual information, this is Michael's laptop, this is Raju's laptop, this is CI, this is this agent running in the CI cluster. Not only, sometimes you have people like me who are like screaming at the top of their lungs that their build failed. Whereas there are lots of people in a team, who just tend to like, bite their tongue and just chug along the day. But so what ends up happening is the most vocal developers' issues get fixed because they are so vocal. But folks who are sort of trudging along every day, their problems never actually get exemplified. And so what you're doing is you're going the reverse of the Pareto principle. Rather than 80-20, you're tackling the 20, which no one cares about. I care about it, but no one else cares about it. And so having all that metadata, not only can I see for a particular issue, who's the affected folks, but what agents were, or what laptops were affected, or what machines were affected, and sort of try and triangulate, isolate, and attack the ones that are affecting more than just the most vocal ones, right? So to sort of circle back to the original definition, you bring these two together, you bring the build scans together and the build cache together. Not only are you decreasing the amount of time it takes to build and test your code, you're also decreasing the amount of time it takes to debug a bad build. And potentially, if you are a developer who's interested in build tooling and you're looking at it and saying, what can I do today quickly that will help a large portion of my team? a dashboard like that can help you isolate certain things that a majority of your developers are facing. That could be bad builds, there could be flaky tests, there could be regressions, and then say, okay, I see everyone's getting affected by this, I'm going to go fix that. And so whether that's a part of productivity or not, it does make a difference, right, to your entire team.
Sorry, every time you say flaky, I hear the that YouTube video. But anyway, so we're getting close to time, and so I want to ask where we go from here, just to kind of wrap it up, bring it home, and we've also, if you've got any more questions, keep them in the coming in the chat as well. But
yeah, so I can, I've got, I'll share this, but there's a really great video by Hans, Dr. Hans, who's the founder of Gradle, on YouTube. If you are sort of curious about what all this is about, I would recommend Gradle and I, your humble host, actually run Gradle Enterprise workshops at least once every 6 weeks. So if you were to go to these links, and I'll post them all in the chat in a second, there's one coming up next week on Wednesday. It's a 2.5-hour deep dive into the Gradle Enterprise and developer productivity engineering. We talk about what problems developers face and how a tool like Gradle Enterprise can help you alleviate some of those pain points with certain solutions. And while this may sound niche, I think I'm allowed to say this, big organizations like LinkedIn actually now are spinning off developer productivity engineering teams whose entire focus is improving developer experience. And that could be builds, that could be testing, that could be, and I know Michael and I just had this conversation about mono repo versus multiple repos. I mean, all of that matters, right, to improve your developer productivity experience. So I'll post these in, let me just make sure before I forget. I know I had it in my clipboard. Give me 1 second.
And you might have covered this when you're talking about some of the stuff that some of these organizations are doing. But a question came in from Jonathan. Is anyone having success doing analytics on developer or development statistics to improve productivity?
So I'm sure other people will chime in, but while we are waiting, development statistics are a function of having, well, statistics, right? And when it comes to especially like the build side, the test times, the regressions that come in builds, broken builds, flaky builds, there is no tool that allows you to measure that right now, not that I know of. You have some semblance in CI systems that measure and track times, but there is usually no like dashboard that allowed to give you an overview of how your builds are doing over time. So I think if organizations have that information at their tooltips, they can potentially try and figure out what to do with them, right? You can only have a KPI if you have an eye, right? And then you can sort of try and figure out what KPIs to build. But with developer productivity engineering, Michael, a lot of organizations are actually building KPIs around builds per week by a team, time for a build, time for testing. I think Mark said this, that the key is test optimization. But if no one's watching, nobody cares, right? If somebody is watching, whether that's even just you watching your own build times, over time, you start to care about what can we do to optimize our test suite, right? Can we figure out a way to parallelize it? Can we figure out a way to create the setup and teardown of databases in containers so that we are not running against a real database? It's easier to throw away a container than it is to reset a database, right, in real life. whatever techniques you come up with, it's a function of having the numbers in front of you. And to that extent, if you look at something like Gradle Enterprise, it's actually an appliance, but it's also a data platform. And so all of the data that we are sort of collecting as build scan data is available to you in REST APIs. So you can build additional dashboards. You can build additional alerting mechanisms. You can do whatever you want with the data. It's your data. You should be able to use it. And so to Jonathan's point, yeah, there are companies that are building KPIs around build metrics and test metrics and coverage and how often, how many you're doing. Of course, lead times, become a post-build KPI, but lead times are a big KPIs in big organizations. How quickly does a change make it to production? And a large portion of that is build, right?
Build and that whole pipeline.
Yeah.
But exactly. And if you've got that, that's a great point, actually. If I make a change that affects this module here, and we've got to deploy all of these modules collectively, but only this one has changed, then we don't need to run the build on those other modules. We don't need to run the individual unit test on those modules. So we've got a much more finely grained deployment process.
Yeah, and that's, if you have separate build pipelines, that's easy to do, right? But if you have a multi-module project, whether that's Gradle or Maven, it becomes harder. But the minute you have something like the build cache, let me just see if I can pull that up real quickly. So here's an example, and perhaps this, let me just see if I can present this. Okay. So, to your point, Michael, let's say you had a project that looks like this, and you started to change it, right? So let's say you changed this blue box up here. Notice the dependency graph. Export API depends on core, service depends on core, and web app depends on service. To your point, without something like build caching, in this case, with build caching, when you change this, your build is smart enough to only run these yellow steps. Everything else can be just pulled from cache because it hasn't changed. Let's say you change the service. Well, everything about the test compilation, check style, and test has to change. And the web app has to be recompiled because you're changing the public interface of the service, but everything else is still green. If you change an implementation detail in this guy, guess what? He doesn't have to build again. You just refactored a method. You didn't change the signature. You didn't change the interface. Now only 2 boxes have to be built. So to your point, things like build caching may seem like they're only good at the macro level, like when I switch branches or when I work with a new repository or whatever. But even at the micro level, within a project, you can get huge benefits. In fact, in this entire scenario, the only time that you get almost 50% yellow and 50% green is when you change a public method in the core module that everybody depends on, whether directly or indirectly. And how often does that happen? So great point, Michael. Yeah, absolutely.
And in the meantime, I can kind of keep going through my process without having to rebuild all of that constantly.
Yeah, it's a hugely impactful, subtle but impactful addition to your toolkit that you are not constantly having to face churn when there isn't churn, right? I make one change here, the implications of that may not be as far-reaching as we think they are, but tools that are typically built in a traditional mindset tend to build quite a bit. And for what it's worth, and not to dismiss anything, but if you've worked with Golang, that's actually one of Golang's strengths, is that the build is intelligent enough to only build the things that have changed. And build times in Go are actually a metric that they measure when they're designing new features in the language. As they're making enhancements to the compiler, build times are a metric that cannot exceed. So it has to be a linear build time, no matter how big the project that you're doing. So it's a pretty cool, this is becoming pervasive in the industry. The developers are asking for, we are not, Rust, actually, one of the biggest complaints folks have is building it takes a long time. And there's good reason for it. I'm not dismissing why it happens, but that's one of the biggest complaints. Is I build this and it takes like 4 minutes, and that's just the nature of the game. And that's something they're working on.
Well, this is all really cool stuff, and I'm glad you talked about this little component of it as well, because I see a lot of benefit there just day to day as a developer. We've got to wrap up. We're getting close to time. Is there anything you want to say in closing?
All I can ask folks to do is I keep saying going back to work in all of my sessions, but no one's going back to work. Everyone is at work all the time. Just, if you are a developer who, maybe one question to ask yourself is this a concern for you? Are build times becoming untenable? Are test times untenable? And what can you do about it? Now, a lot of folks that I speak with say, well, that's not usually my problem, that's a CI problem. And hopefully I've convinced you that it is our problem. Yes, you might have a dedicated CI team that manages some things for you. They might manage your CI infrastructure, but they can't help you debug a bad build. They don't have enough information. Things like build scans can help you bridge that gap and say, hey, I ran this build and that build ran on your infrastructure and it broke. So here's the comparison. Can you, and I spot that this was different. So either I'm wrong or you are wrong and one of us should fix it. So again, going back to this idea of collaboration, transparency, regardless of how you spin that story, developer productivity experience, you can take it in your own hands, right? Whether you're just someone interested in tooling or automation or builds or DevOps, experiences matter. So, and talent matters. I know I walked out of projects where if you've used a WebSphere or something and the build time is like 22 minutes, I'm like, see ya. Talent matters. So go back, think about it. And if you're curious, I've posted the links. The last one, if you want to see more of me next Wednesday, I'll be there at noon on Wednesday, doing a 2.5-hour workshop on developer productivity experience, and it's free. So other than 2.5 hours of your attention, there's not much of a cost. So pull yourself in, pull your team members in, see if there's something that tickles your fancy, and then take it from there.
Wonderful. Well, Raju, thank you so much for your time and your expertise. And for everybody out there, thank you for tuning in. Do check all the upcoming stuff at nofluffjuststuff.com. But until then, until we can get together in person, thanks for your continued support and stay safe out there.
Good afternoon, Mr. Raymer. Everything is going extremely well. Let me put it this way, Mr. Raymer. The 9000 series is the most reliable computer ever made. No 9000 computer has ever made a mistake or distorted information, so I am constantly occupied. I am putting myself to the fullest possible use.
T-E-S-T-I-N-G, that's for them but not for me. I know I write perfect code, I don't need no TDD. Nope. All the tests are so flaky, 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 flaky. Test suite is so janky, 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 janky. T-E-S-T-I-N-G.
Actually, two things. One, you
Are you
are still
still
recording. Yeah, you're still recording, and also, so you should probably stop that. I don't have the button to stop it since you're the host now.
Yeah, I was waiting to see anyone had any questions, but I'll end it.
Oh,
Wait,
there's your.
end
There's your.
the